Hey guys, Russ Tyndall with Blue Line Wood Flags here. Today we have a really cool project that is a bit of a departure from what we have done in the past on the channel. We're going to be using a JTech 4.2 watt laser to burn, or etch as some people call it, a design onto a piece of wood. The laser itself attaches to the front of the Axiom CNC machine by way of an included bracket. This isn't a demo video of how to install the laser. Axiom includes really good instructions for that, and those instructions are super easy to follow. Believe me, if I can follow them, so can you. This is a project video that was fun to create, and it's so easy you can do it too. This is what we're going to make. What we have here is a 12 by 16 inch piece of hard maple with the Marine Corps globe and anchor symbol and text which reads Marines above it. This was all created with one simple tool path. What we're going to be doing now is going to dive into VCarve Pro, and I will show you my workflow on how this project is made. Keep in mind you can do this with any design. I just happened to pick the Marine Corps globe and anchor symbol. After we create the design and specify our single tool path and save it to a flash drive, we're going to go out to the shop where I will demonstrate the process for starting up the laser and completing the project. Come on, let's go have some fun. All right, folks, let's get rolling. I am using VCarve Pro. This will work if you have Cut 2D, VCarve Desktop, or Aspire. Let's get started. The first thing we're going to do, and before I go any further, let me say that my intentions here are not to show you VCarve Pro. I'm not an expert in VCarve Pro. There are many of you that probably know quite a bit more about this than I do. So if you know faster shortcuts of accomplishing the same thing that I am going to show you, by all means use your methods. Again, I'm not here to show you VCarve Pro. I'm going to go ahead and we're going to start by creating a new file. The job setup is where we're going to begin on this. It's a single-sided project. My width on this is actually going to be 12 inches wide, and it's going to be 16 inches in height. Thickness, the piece of maple that I'm actually using on this is a 1/2 inch thick, but we're not carving into it. We're burning the surface with a laser, so thickness is not a variable for this. Z0 position will be material surface. Very seldom do I ever use the machine bed for any of my projects. XY datum position is going to be the center of the workpiece, as you can see here. And modeling resolution, we're just going to leave as it is. Doesn't apply here. So we'll select OK. And as you can tell, that gives us our workpiece that we are dealing with. 12 inches wide, 16 inches in height. So before we go any further, we're going to need to bring in our vectors. And what I like to do in my workflow, especially for complex vectors, is I do all my design work in Adobe Illustrator. And if you have a similar type software suite such as CorelDRAW, that will work just as easily. Anyway, I use Adobe Illustrator, and if you come up here to import vectors, we're going to go and find the vectors that I've already created for this project. I happen to have them stored on another drive in a file folder called EPS, and it's under Marine. So let's bring in the Marine Corps. If I use my scroll bars, you can see what we're dealing with here. And right now they're ungrouped, so I need to group everything. So if I hit G on my keyboard, that's the shortcut command for group, or you could come over here, let's see, where is it? There, group. This, by clicking on this, would do the same thing. So everything's grouped now, and I want to center it, so I'm going to hit M on my keyboard for move, or if I wanted to do the click part of it with the mouse, I could just click here. I want to do an absolute move to take it to an exact absolute location. Relative just means I'm moving it relative to its current location, but I want it to go to a specific location, so I'm going to select absolute, and I want it to go in the middle, so I'm going to put 0 for the X position and 0 for the Y position, and we'll select apply, and as you can tell, that moved it right to the middle of the workpiece. So this is what we're going to be etching onto the wood with our JTech laser. So we're going to come up to tool paths, and let's pin this down so it doesn't hide on us, and we can keep it visible. Axiom recommends that you use a quick engraving toolpath, and I have found that that works excellent for using the laser. So we're going to select the quick engrave toolpath. As you can tell, my tool has been pre-populated with JTech 4.2 watt laser. I have found that for the majority of my projects that a step over of 70% works great, and that a feed rate on the laser of 70 inches per minute works fantastic. I'm primarily cutting into wood, or burning into wood, I should say. I haven't used this for metals or leather or plastics or anything else. I'm not sure it would work good on plastics. But I have found that these settings work great for the projects that I have done. Keep in mind, though, that different wood species are going to burn differently. Harder woods, such as hard maple, are going to have a very light burn on them. And that's just because the wood is so dense. An oak, for example, is a little bit is not so dense as maple, so it's going to allow that laser to penetrate a little bit more. Your burn is going to be a little bit deeper. And pine, being a softwood, is going to even burn deeper than that, and it actually will give you a slight discoloration around the burn, like a tannish color. You'll see if you do that. And that's just if you use these settings, these same settings on all three species of woods that I've just mentioned. My recommendation is to always do a test burn on a piece of scrap just to see what your results are, and make sure that you're happy with the results on the scrap before you go and do your final project. So anyway, these are my settings. Like I say, I like it. It works for me. It may not work for you. Just like I say, double check and make sure you got your machine dialed in before you do your project. So we'll go ahead and we'll select OK. And the next thing we're going to specify is whether it's just an outline or whether we are dealing with a fill. I'm going to select fill because I want all my vectors filled in. If I went with just outline, just the outline of the letters in Marines would be filled, but I want to fill it all in. I like a hatch angle of 45 degrees. That means that the laser is going to be running at a 45-degree angle. It's not going to be going this way or 90 degrees straight up and down. I like a 45. I think that just adds a little bit more class to it. And then a cross hatch would just be, it would actually cross it perpendicular to what your original specification is here. Nose cone doesn't apply. We're going to have to name it something. It's just suggesting quick engrave 1 here. I'm going to call it MARINE. And as you know, if you've used the Axiom pendant before, it's quite specific on the amount of characters that it allows you to see. If you use anything more than 6, it abbreviates it with a little tilde symbol. So I try to keep all my names 6 characters or less, and Marine happens to be a 6-character word, so we're just going to go with that. Post-processor, Axiom provides you instructions when you purchase your JTech laser through them how to download their post-processor. There's 2 different post-processors for Axiom. There's their regular one, which is Axiom HHC CNC, and then they have Axiom HHC laser. So just be aware that you're going to need to select the correct post-processor after you install the laser post-processor. You're going to have to select the correct one for the project. Don't inadvertently select CNC. You're probably going to wind up with some results that are funky, or it's not going to work for you at all. So we're just going to make sure laser's selected. Come on, calculate it. It's a big toolpath. There's a lot of vectors that it needs to run, so it may take a minute. There we go. Let's hit cancel for now. We don't want to save it just yet. But I do want to show you on the 3D view what it's going to look like. So this is how it's going to etch onto the piece of wood. If I was to, let's get this off of here, take the toolpath off, because we're not carving into the wood, you're not going to see anything. But if I select it, you can see what the laser itself is going to do. So let's go back to the 2D version. Now, the next step is to save it to the USB thumb drive that we can take out into the workshop and actually plug into the machine. And in order to do that, we do that the same exact way that we would for any other CNC project. We are ready to go, my friends. I will see you out in the workshop. We'll plug her in and we'll get going. What we are doing here in this first segment is removing the dust collection system and hooking up the JTech to the CNC bracket and plugging it in. What I didn't show you that was previously done off camera was establishing the XY0 for the laser. It should be noted there's an 80mm offset between the spindle and the laser itself. In order to get the laser centered accurately, I use a bit in the spindle, center it on the workpiece, and zero the XY. I then move the spindle 80mm in the Y+ direction, which is towards the back of the machine. Once I reach exactly 80mm, I re-zero the XY position. What I'm about to do is adjust the spindle delay. For all laser operations, you need to adjust the spindle delay from 4,000 milliseconds to 0. Press Menu to access machine setup. Press OK, go to spindle setup, press OK again, and select spindle delay. Change the on delay from 4,000 to 0 by pressing the delete button and then pressing the number 0 and then OK. You can press cancel as many times as necessary to return to the home screen. In order to establish the proper Z height, lower the laser unit carefully until it is approximately 1/8 of an inch from the work surface. Once you are satisfied with the position of the laser, you can go ahead and zero the Z-axis. Okay, in order to get the laser unit on and operational, we're going to go ahead and we're going to press the toggle switch to the rear to the laser position. Then we're going to press the little red detent on the circuit board. We're going to press that down, then we're going to turn the key to the right 1/4 turn and turn the toggle switch to the on position, the little power button. You should see one light, one green LED lit. Then if you look at the top of the fan on the laser unit itself, it should be spinning. The next thing you see me doing is putting the USB flash drive into the pendant, just like I would any other CNC project. And of course my safety glasses go on. These lasers, if you look at them with your eyes, you can lose your eyesight, so always wear the glasses that come with the unit. And we're just going to run the marine project just like we would any other toolpath we save to a flash drive, and the whole toolpath will start to run. So kick back and enjoy. Well, I hope this video was useful to you. I sure had fun making it. Please be sure to check out some of my other projects and demo videos that I have on my channel. If you like what you have seen, please smash that like button and hit subscribe to be notified when I post new content. Until then, stay healthy and stay safe. Cheers.